So now the chi-square test for independence of attributes. We are seeing an example problem. The following data was collected in on literacy and smoking. Based on these data, can we conclude that smoking depends on literacy or not? So these are the given data. So here literates and illiterates, smokers, non-smokers. So the question is, can we conclude that the smoking depends on the literacy? అంటే క్వశ్చన్లో ఏమడిగిన మనకి స్మోకింగ్ అనేది లిటరసీ మీద డిపెండ్ అవుతుందా, లిటరసీ అంటే చదువుకోవడం అనేది ఏమన్నా స్మోకింగ్ అనేది ఏమన్నా ప్రభావం చూపుతుందా లేదా లిటరసీ మీద అనేది క్వశ్చన్. సో ఫస్ట్ we need to set up the null hypothesis. How to set up null hypothesis? So here in the given the question, can you conclude that the smoking depends on literacy or not? So here we are setting the null hypothesis means, so null means nothing is happening. So here we are writing the statement, smoking does not depends on literacy, right? So this is the null hypothesis statement. Now the alternative become opposite of this one, which is given in the question as it is. Smoking depends on literacy, right? So here see, the question is in the form of 2 cross 2 matrix. So here given only 4 values, so 2 cross 2 contingency table is given. So we need to use the formula chi-square is equals to n into ad minus bc whole square by a plus b, a plus c, b plus d into c plus d. So that formula we can follow. Chi-square is equal to n into ad minus bc whole square by a plus b, a plus c, b plus d, c plus d, which follows chi-square of r minus 1 into s minus 1 degrees of freedom. So here I am taking the attributes as a and b. So capital A represents the literates and illiterates, literacy, and the attribute b represents the smoking. And here the remaining attributes in a1 means literates, a2 means illiterates, smokers, b1 means smokers, b2 means non-smoker. So I am representing these literates, illiterates, smokers, non-smoker as a symbols or as attributes b1, b2, a1, a2. So here in the first cell it is small a, b, c, d. So this is the form of contingency table. So we need to find the totals of rows and totals of columns as well as. So 83 plus 57 140 and 45 plus 68 113 and 83 plus 45 is 128 and 57 plus 68 is 125. So when we add this total, 125 plus 128 is equal to 253. So when we are adding these two totals, we need to get the same value. So this 253 value is capital N. represent the capital N value. So now our formula is chi square is equals to capital N into AD minus BC whole square by A plus B, A plus C, A plus B and A plus C and B plus D and C plus D. So A plus B total is these two. This is the A plus B, here C plus D, here A plus C, here B plus D. So simply substitute in this formula. N is 253, AD means 83 into 68 minus BC 57 into 45 whole square divided by A plus B is 140, A plus C is 128, B plus D is 125 and C plus D is 113. So calculate. into 68 minus 57 into 45, 3079 and which is the square 948024 and it multiply with 253, so we will get the answer 23985000973 divided by, so denominator values are 140 into 128 into 125 into 113, that is equals to 25312,000. Right. So 23985000973 divided by 25312,000, which is equals to 9.4757. So this is the chi-square calculated value. Chi-square calculated value is equals to 9.475. So now we need to find the critical value, means the table value. Chi-square table value when the degrees of freedom is r minus 1 into s minus 1. R minus 1 into s minus 1 means r represent the rows, s represent the number of columns. So we are having 2 cross 2 matrix means we have 2 minus 1 into 2 minus 1, right? So that is 2 minus 1 1, 2 minus 1 1, so 1. So degrees of freedom is here 1. So now we need to check chi-square table values. So here the level of significance is alpha is equal to 5% and the degrees of freedom is 1 we are getting. So the value is 3.84. So chi-square table value is equals to 3.84. So chi-square calculated value is more than table value. So chi-square calculated value is more than chi-square table value, which means the H0 is rejected. So the inference will be, what is the inference? H0 is rejected means H1 is accepted. What is the H1 statement? The smoking depends on literacy. The smoking is depends on literacy. We need to write the conclusion. So the next example problem is the data on the hair color and eye color are given in the table. Determine the association between the hair and eye color. So this is the given data. We need to check, is there any association between hair and eye color. So here the given table is not in contingency table like 2 cross 2 table. So here we need to use the chi-square formula as double summation Oij minus Eij whole square by Eij. So now we need to find the expected frequencies for these two entire table values. So first of all we need to set up the null hypothesis. So null hypothesis, how to write null hypothesis is the question, is there an association between the hair and eye color is there or not, he is asking. So we need to write here the null hypothesis statement, there is no association between hair and eye color, right? So simply alternative, it becomes alternative hypothesis is H1 colon there is a association between two colors or hair and eye colors, right? So now the test statistic under H0 is H0 is chi-square is equals to double summation where r I is equals to 1 to r, j is equals to 1 to s, formula is Oij minus Eij whole square by Eij follows chi-square of r minus 1 into s minus 1 degrees of freedom. So this is the formula for, we need to use here double summation Oij minus Eij whole square by Eij, right? So when we using this formula we need to find the expected frequencies for these all the remaining cell values. So these are the observed frequency values, means Oij values are, these are the Oij values. So we need to find here Eij values. Eij means expected frequencies. So here in the table directly is given the total values already. So in some cases it is not giving the total values. So we need to find the total of these particular rows and all the column values. So now I am representing these eye color as attribute A, hair color as attribute B. So these sub attributes are A1, A2, A3. These are B1, B2, B3, right? So that is representing the another table. So this is the table I am representing the attributes. So now is here given the totals in the directly in the question. So this is the total of attribute A. So it means A1 attribute frequency, total of sum of total of attribute A1. So this is A2. This is when containing some parentheses or brackets, it means some frequency of the A1 attribute, right? So here B1, total of B2, total of B3, right? So now we need to find the expected frequencies. How to find expected frequencies? So using the formula, so we need to find the first cell expected frequency now. So that is E11, first row first column. E11 is equals to A1 into B1 by capital N. A1 into B1 capital N. So that is A1. So total of A1 is 40 into B1. B1 is 60 by N. What is N? 150. So this is N. So this is N, that is 150, which gives the value 16. Right. So next cell is E12. E12 is A1 B2 by capital N. So A1 total is 40 into B2 is 60 again 150. So again 16 we need to get. So E13. So E13 means this cell expected frequency in the formula A1 B3 by capital N. So A1 is 40 to B3 is 30 by 150, that is equals to 8. Next, the first row expected frequencies are completed. Next, the second row E21. E21 means A2 into B1 by capital N, that is equals to, what is A2? 50 into B1. B1 is 60 by 150. So here we getting 20. Next E22, that is A2 into B2 by capital N, that is A2 is 50, B2 is also 60 by 150, means getting again 20. So E23 means A2 into B3 by capital N, that is equals to A2 is 50 into B3 is 30 by 150, that is equals to, we are getting 10. So next, third row E31, A3 into B1 by capital N, that is equals to, A3 value is A3 total 60 into B1 is 60 by 150, that is 24. Next E32, A3 into B2 by capital N, that is equals to, E3 is 60 into B2 is also 60 by 150, that is equals to 24. The last value is last cell expected frequency A33, that is A3 into B3 by capital N, that is equals to 60 into 30 by capital N, that is equals to, we are getting 12. So these are all are the expected frequencies. So now we need to write observed frequency, expected frequency values in the table. So observed frequency means the given question, that is 15, 20, 5, 20, 20, 10, 25, 20, 15. Next, expected frequencies means whatever they are finding in the table previously, that is 16, 8, 20, 20, 10, 24, 12. So Yj minus Ej, so difference between these two is minus 1, here 4, here minus 3, 0, 0, 0, 1, minus 4, here 3. So square by Oj minus Aj whole square by Eij. Eij means here 1 square minus 1 square by 16. Minus 1 square by 16 means 1 by 16, that is 0.063. Next, 4 square by 16 means 16 is 1. 9 by 8, 1.125. Here 0, 0, 0. 1 by 24 is 0.0467. Next, 16 by 24, that is 0.6667. Again 9 by 12. 9 by 12 is 0.75. So when we add up this all, so these are the calculated values. So now we need to add these all values. So we are getting here 3.65. 3.65 is the chi-square calculated value, which is the chi-square calculated value is 3.65. Now we need to find the table value is chi-square table value at degrees of freedom is r minus 1 into s minus 1, that is equals to r minus 1 means 3 rows are there, 3 columns are there, so 3 minus 1 into 3 minus 1, that is equals to 4. 2 into 2 is 4, so the degrees of freedom is 4, and we need to find the table value. So chi-square table value is 9.49. 9.498 5% LOS. 5% LOS. So here the calculated value is within the tabulated value, so that is chi-square calculated is less than chi-square tabulated value, so therefore H0 is accepted. That means the conclusion will be, what is the conclusion? Hence there is no association between hair color and the eye color.